Good morning, Middle 3. Today we have the last lesson in the trick, which talk about some important remarks, and these remarks are very important to study the trick in Middle 3 and Senior 1, inshallah. Okay? You can open your booklet, page 14. We have 4 remarks. These 4 remarks are very important, as I told you. We will talk about one by one and how we get it in the exam. Page 14. The first one, talk about the relation between the two complementary angles in the right angle triangle. So this is important remarks. The first one, if I have the triangle ABC, right angle at B. What is the relation between angle A and C? Excellent. The two angles A plus C, it will be equal 90. So they are called complementary because we have studied before the two angles whose sum equal 90, they are called complementary angles. So since measure of angle A plus measure of angle C equals 90, we talk about what? We talk about the complementary angles. We have a very important remark to talk about these two complementary angles. Sine A, it will be equal cosine C. Why? Because these two angles are complementary angles. And cosine A equal sine angle C. This remark only for the two complementary angles. I can give you an example on this part. If I give you sine 35 equals cosine dots. How we complete this one? Excellent. I have sine equal cosine. So these two angles are complementary. The first one is 35. So how we get the second one? I have to subtract 90 minus 35. It will be 55 degrees. Understand it? Yes. Excellent. So the second one, if I give you sine 30 equal cosine dots. You can get this one from the special angles which we talked before. Sine 30 equals half. And which angle whose cosine also equal half? Excellent. It will be cosine 60. You can check by using calculator. Sine 30 equal half and cosine 60 equal half. So why they are equal? Because 30 and 60 are complementary angles. This is the first remark of our lesson today. You understand? Okay? Okay. The second one, which we have it on page 14, we have another rule for the tan. We have studied before tan angle A equals opposite over adjacent, right? If I give you this triangle A, B, C, right angle at B, and this side 3, and BC is 4, and AC it will be 5. And I ask you to find sine angle C or A to be the same way. Sine angle A. What is the sine? Opposite over hypotenuse. So it will be 4 over 5. And cosine angle A adjacent over hypotenuse, it will be 3 over 5. Right? If I divide this sine A divided by cosine A, it will be 4 over 3. Right? Look at the triangle. How we get 4 over 3? The 4 is opposite to angle A and 3 is adjacent. Which ratio? 10. So tan angle A equals sine A over cosine A. You can check it by using calculator. It will be 4 over 5 divided 3 over 5. It will be 4 over 3. The same answer if I divide the opposite over the adjacent directly. This is the second rule. So tan any angle, it will be opposite over adjacent or sine over cosine the same angle. Okay, so we have two rules to get tan any angle. Okay, you understand it? The third part which we have it, or the third remark, talk about also the two complementary angles. Yes. By the same way, number 3, if I give you this triangle, A, B, C is right angle triangle at B. Okay? And I have this side 3 centimeter and this side 4 centimeter. And angle A and the angle B are complementary angles, right? So if I ask you to get tan A, you can tell me tan A, opposite over adjacent, 4 over 3. And who can tell me tan B equals 3 over 4, opposite over adjacent. What we have now? Excellent. Tan A and tan B are two multiplicative inverse. So if the two angles, since measure of angle A plus measure of angle B equals 90, or two complementary angles. Therefore, tan A and tan B are multiplicative inverse. So if I multiply any two multiplicative inverse by each other, what we get equals whole 1. This is the third remark. You understand it? Okay. The last one, which we have it, talk about the area of the triangle. The area of the triangle. This is number 4. Area of the triangle. Who can tell me the rule of the area of the triangle, which we have studied before? If I have height in the triangle, if I have a triangle like that, and I have height, okay? How we get the area of the triangle? ABC is a triangle like that, and AD is the height. So I have height. This case, I have height in the triangle. This height 3 centimeter, and the base BC is 8 centimeters. Excellent. We have studied before the area equal half times base times height. So where is the base and where is the height? Half times the base equals 8 and the height equals 3. So the area equal 12 centimeter power 3. Excellent. This is the first case which we have studied before. So this case we have studied before. Now we have the second case and the new rule. If there is no height, if there is no height in the triangle, I have a triangle like that. He give me a triangle. And there is no height. He give me this side 6 centimeters. And this side 7 centimeters. And this angle 30 degrees. Angle B. And he asked me to get the area of the triangle. And there is no height. Okay? We have a new rule. To get the area of this triangle, it will be half times the product of the two sides, which given AB times BC, okay, times sine the angle which included between them, which is sine angle B. So how we get the area of the triangle? It will be half AB 6 centimeter and BC 7 centimeter, and sine B means sine 30 equals half. If you calculate this on the calculator, we get 10.5 centimeter square. Okay, this is remark number 4, and this remark is very important because we have a new rule to get the area of the triangle without height. To get the area of the triangle without height, I have to get two sides and the measure of the included angle between them. Okay? This is our lesson today, middle 3. And now we have finished unit 1, which is the trigonometry. Okay? And you have homework in your booklet. You can solve page 23 in the geometry booklet. Okay? Thank you, middle 3, and goodbye.